Hi ladies, this is Mrs. Blaufuss and this is lesson 4.8 and it's about using the quadratic formula in the discriminant. So a couple key vocab terms. First of all, I'm going to define the quadratic formula first. And this is a formula that you've probably used before, but we're going to use it in addition to the other methods that we have for solving quadratics. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and the discriminant is this part here, the part that's inside the square root side. So the discriminant is b squared minus 4ac. And b squared minus 4ac, that is for any quadratic equation that's in standard form. So you can find the discriminant even if you don't set it all up into the quadratic formula. It's of any equation that's in standard form, ax squared plus bx plus c. You can find the discriminant of that. All right, so those are two key vocab terms. Now we have done completing the square already. So in part 2, I'm not going to walk through this whole thing in this video. I'm going to try to keep this a little bit shorter, but in part 2, you can see how we actually get the quadratic formula by completing the square. So again, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, part 2, watch that if you want to see actually how we get the quadratic formula by completing the square. That's where the formula comes from. It's just a generic complete the square. So with this quadratic formula, when you use this, there's a few steps that you should follow. So the first step is to write the original equation. Whatever form your equation is in, put it in standard form. And this is standard form. So the first step is to write the original equation. Second step is to write it in standard form. The third step to use the quadratic formula is to find A, to find B, to find C. Then you can plug those values into the quadratic formula. And then lastly, and this is important, make sure you simplify. Actually, not lastly, because we should always check your answer. And we'll go through a couple of different ways you can check your answer. You can always use substitution to check your answer. So plugging your x value back into the original equation, or I'll show you how to use your calculator to check too. So always do those things when you're using the quadratic formula. So we're going to do a couple practice problems here. So we're going to use the quadratic formula, which again is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So our first step is to write the original equation, which is done. Put it in standard form, which is done. And then the third step is to identify a, b, and c. So here, a equals 3, b equals negative 3, and c equals negative 5. So that's of the standard form ax squared plus bx plus c. So that's where our a, b, and c come from. And then we can put it into the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a, oops, actually put the value in for a, 4, oh gosh, here we go, 4 times a, which is 3, and c, which is negative 5, all over 2 times a, which is 3. Okay, so now we can simplify this. X equals negative negative 3, which is positive 3, plus or minus the square root of 3 squared, which is 9. And then 4 times 3 is 12. And 12 times negative 5 is negative 60. So minus negative 60 is plus 60. And just in the interest of space, I'm just going to combine this right now. So the square root of 69 all over 6. So that is x equals 1/2 plus or minus square root of 69 over 6. All right, now really that's your answer. But to double check this, we can actually evaluate this answer. So we're going to check, and we'll do this with all of them. So that's, and decimal form is fine when you're just checking. So that's 1/2 either plus square root of 69 over 6 or 1/2 minus the square root of 69 over 6. So let's see what the square root of 69 over 6 is. So square root of 69 over 6 is about 1.38. So it's either 1/2 plus 1.38 or 1/2 minus 1.38. So it's either 0.5 plus this or 0.5 minus this. So it's either 1.88 or negative 0.88. Okay, so now let's use our calculator to actually check this. And this is just to check this is not how you solve. Because when you solve, you should get those exact answers using fractions and square roots and simplest form and all that, not just a decimal. But to check, you can use your calculator. So to check, plug in your equation, 3x squared minus 3x minus 5. And then go ahead and graph it. Oh, it looks like my window is way off. I'm just going to put just our standard window. right, so here's just your standard window. And so we did this in the last lesson or maybe a couple lessons ago, but you want to press the second and then the calc button and scroll down to 0. We're looking for our zeros. And then it asks you for the left bound to make sure your cursor is on the left-hand side of your 0, which is where it intersects with the x-axis. And enter. And then it asks for your right bound. So scroll somewhere on your graph that is on the right-hand side of your intercept. And hit enter. And it'll say y is 0 and x is negative 0.88. Okay, so that's one of our answers. And then if you find the other 0, so do the same thing, second, calc, looking for zeros. Scroll, trace along your graph, somewhere on the left-hand side, and somewhere on the right-hand side for right bound. And it says your 0 is x equals 1.88. And that is the other answer that we have. So 1.88 or negative 0.88. So that's how you check your answer. It is not how you solve, it's just a check. All right, then looking at example 2, we've got x squared plus 4x plus 11 equals 7. So the first thing we want to do, we have our original equation, we want to write it in standard form. So that's x squared plus 4x, move 7 over, so we're subtracting 7 from both sides. So we can set that equal to 0. Then we're going to identify our a, our b, and our c. Then we can use that and plug it into the quadratic formula. So x equals negative 4 plus or minus the square root of b squared, which is 16, 4 squared is 16, minus 4 times a times c, all over 2a. So we can go ahead and simplify this. Negative 4 plus or minus 16 minus 4 times 1 times 4 is 16 minus 16, which is square root of 0, which is just 0 over 2. So we have x equals negative 4 over 2 plus or minus 0 over 2, which is just 0. So we have x equals negative 2. So again, we're going to check by graphing. So if you go back to your graph, go to y equals, clear out what you already have in there. And go ahead and enter x squared. Oops. X squared plus 4x plus, remember to use your original equation or your standard form equation, and then go ahead and graph that, and you can calc, find the zeros, and it asks you for the left bound first, and looks like this one hits the graph exactly. The minimum looks like it is your intercept. So our calculator gives us 2.000001, which is basically negative 2, when y is 0. So negative 2, that answer checks out. All right, so I'm going to do this next one, but I'm going to skip the checking on the calculator part. So we did a couple checking on your calculator, so we'll just solve it using quadratic formula. So again, the first step is you want to put this into standard form. So we've got x squared plus 3x minus 10 equals 0. A is 1, B is 3, and C is negative 10. So we can plug that into our quadratic equation, where we have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So then when we simplify this, we get x equals negative 3 plus or minus 9 minus 40. 9 plus 40, sorry, which is 49, all over 2. So we have x equals negative 3 over 2 plus or minus 7 over 2. So you have to actually simplify this. You can't just stop here. Yes, this is the answer, but it's not in simplest form. So negative 3 plus 7 is 4 over 2, which is 2. Or x equals negative 3 minus 7, which is negative 10 over 2, which is negative 5. So here are our two solutions. And again, if you graph that, you will see those as solutions on your calculator. And again, that's just a way to double check. That's not how you solve the problem. All right, and then the last one, x squared minus 4x equals negative 8. Again, we want to put this into standard form. So we've got x squared minus 4x plus 8 equals 0. And we'll define our a, our b, and our c. And we can use the quadratic formula. X equals negative 4 plus or minus b squared minus 4 times a times c all over 2 times a, and then we can simplify. So x equals 4 plus or minus 16 minus 32 all over 2. So x equals 4 over 2, which is 2, plus or minus, and this 16 minus 32, that's the square root of negative 16. So when we simplify the square root of negative 16, we get x equals 2 plus or minus 4i over 2. And simplify again. X equals 2 plus or minus 2i. Now for this one, since you don't have any real solutions, because this would be 2 plus 2i is an imaginary number, and 2 minus 2i is an imaginary number. So you have two non-real solutions. They're not going to show up on your graph. If you try to graph them, you're not going to get a non-real solution. So for this, in order to check your answer, you have to go back and use algebra. So use substitution. So substitute in 2 plus 2i, and substitute in 2 minus 2i, and for x, for both of those, and you should get negative 8 both times. Okay, the second part is using the discriminant. So the discriminant, again, is that b squared minus 4ac. So here's your discriminant. So you have three options. It's either equal to 0, it's greater than 0, or it's less than 0. And we're going to use the discriminant to tell us how many and what kind of solutions we have. So if the discriminant is greater than 0, then we have 2 solutions, and they're both real. So 2 real solutions, and your graph will look like this. So you can actually check your solutions using that calc button on your calculator. If you have 1 real solution, your solution is going to be the minimum or the maximum, and it's going to intersect with the x-axis. That's going to be your 1, 0, if the discriminant is equal to 0. 1 real solution. If it never intersects, and that was the example that we just had here when we had 2 imaginary solutions, or 2 non-real solutions for this example 4. So 2 non-real solutions. Our graph, if you actually graphed it, you would see something like this where it never intersects with the x-axis. So this is 2 imaginary solutions. So this next part is just finding the value of the discriminant. And again, you can use your calculator to check these answers. They're all already in standard form. So just double check your graphs. But the first one, again, you want to define your A, your B, and your C. And your discriminant is B squared minus 4AC. So for the first one, we've got 2 squared minus 4 times 1 times negative 3, which is 4 plus 12, which is 16. 16 is greater than 0. So without even finding the solutions, you know that there are 2 real solutions because the discriminant is greater than 0. Right, for the second one, same thing. We're going to use B squared minus 4AC. And we're going to identify our A, which is 1, our B, which is 2, and our C, which is 1. So B squared, that's 2 squared, 4, minus 4 times A times C. 4 minus 4 equals 0. 0 is equal to 0. So we have 1 real solution. And this last one, we have 2 real solutions. And we'll check these all at the end. All right, and then our third one, again, our discriminant is B squared minus 4AC. So A is 1, B is 2, C is 5. So B squared is 4. That's 2 squared. So 4 minus 4 times 1 times 5. That's 4 minus 20, which is negative 16. Negative 16 is less than 0. So we have 2 imaginary solutions. So now if you go to your calculator and you plug those all in, and I'm just going to do it all at the same time because I have color coordinated. So my blue one, I'm going to do for the first one, and that was x squared plus 2x minus 3. My second one, which is going to be red on my graph. So my second one was x squared plus 2x plus 1. And then my third one is going to be black on my graph, and it was x squared plus 2x plus 5. Alright, so that's my first one, 2 real solutions, 1 real solution, 0 real solutions. So this first one here, oh, yeah, I can actually pull that in here. Alright, so this was example 5, and you can see here 2 real solutions. This was example 6, and here you can see 1 real solution, and this was example 7, or actually this is C, and this is B, and this is A. Okay, and then example C, you can see no real solutions, it never crosses the x-axis. Right, I know this video is getting kind of long, but not quite as long as the class would be. So this is the last one. This is a story problem. You've seen problems similar to this in the last lesson, or maybe the last couple lessons where we're looking for time. But here they throw an initial velocity. So anytime you see sub-zero, like v sub-zero, h sub-zero, that stands for initial. Initial velocity, initial height, and then ending height. Just h is ending height. So v sub 0 tells us that initial velocity is 4 feet per second. Initial height, it tells us is 40 feet above the water. And ending height, we're going to hit the water, so it's 0 feet above water. So our ending height is 0. So we can use the quadratic formula, but first we need to write it out. So we need to write out our equation. So we have 0 equals negative 16 t squared plus 4t plus 40. It's already in standard form. Our a is negative 16, our b is 4, and our c is 40. Now we can plug this into the actual quadratic formula. And that gives us x is equal to b squared, or sorry, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, and then you'll just have to simplify. And if you calc this out, I put this in my calculator, but if you calc this out, you should get negative 60 all over negative 32. So x equals negative 4 plus or minus so that gives us 1a plus or minus the square root of 2576 for negative 32. Now, use what makes sense. Okay, so if I asked you for an exact answer, you would have to find the perfect square, 2576, and then simplify that way. But this is talking about time, and so if you told somebody this, and we're talking about seconds, they would be like, okay, so is that like 1 second, or 5 seconds, or what? So go ahead and use decimals for this kind of problem. So we're looking for the square root of 2576. And that is 50.75. And actually, this should be t. These should all be t. What did I say it was? 50.75 over -32. And if you calc this out, you should get 50.75 divided by -32 is approximately 1.59. Now, we're talking about seconds. So 1A is 0.125. We cannot subtract. Do not subtract, because then you'll get negative time. You can't have negative time. So t approximately equals 0.125 plus 1.59, which if you simplify that, you get t approximately equals 1.71 seconds. Check on your calculator. So practice using your calculator just to double check your zeros once you solve. Because when you plug that into your calculator, that's exactly what you should get for the positive intercept on the x-axis. Again, you cannot have negative time, so do not use negative time. So please jot down any questions you have and ask them next time I see you in class. Thanks.